Explain to yourself in your own words what are the key takeaways from the video. So the video entitled The Concept of Stability for Electrical Engineers Control System 3.1 is that one of the main ideas discussed in such video is the concept of stability in control systems. So a system is then considered stable if after experiencing some disturbance or excitation, it will eventually come back to its equilibrium or steady state. In other words, even if something temporarily changes the system's behavior, it will still settle back to its normal condition over time. So the video explained this concept using a simple example with a ball and a marble. So in the first scenario, the ball is facing upward and a marble is inside it. The marble is flicked, it will eventually move around the ball for a while, but it will then settle back to the bottom over time. This represents a stable system because it naturally returns to its equilibrium position. In the second scenario, the ball is upside down and the marble is placed on top. If the marble is flicked, it will fall off the ball and will not return to its original position unless someone manually places it back. This represents an unstable system because once it is disturbed, it does not return to its equilibrium state. Furthermore, the video also mentioned that if the marble in the first scenario is flicked extremely hard, it may leave the bowl. This situation introduces the idea of the bounded input and bounded output. A bounded input means that the disturbance applied to the system is limited or within a certain range, while a bounded output means the system's response also remains limited but does not grow infinitely. For a stable system, a bounded input should produce a bounded output. So lastly, the video also discussed the mathematical representation of stability using a transfer function, usually written as g of s, which is just the ratio of two polynomials. From this transfer function, we can identify something called poles and zeros. So the poles are the values of s that makes the denominator equal to 0, and these are very important because they determine whether the system is stable or unstable. On the other hand, the zeros are the values of s that make the numerator equal to 0, and they affect how the system responds to input. A system can have multiple poles and zeros depending on the order of the polynomials. Number 2. Was the video helpful in giving you more understanding of the subject? Why or why not? Indeed, the video is truly helpful because it explains stability in a very simple and visually way. The ball and the marble example made it much easier to understand how a system behaves after disturbances. Lastly, as a future engineer, what are some interesting insights you did gain from this topic? So, as a future engineer, one insight I gained is that stability is a very important factor when designing systems. Engineers must make sure that the system behave predictably and return to its normal conditions after disturbances. Understanding the concepts of poles, zeros, and system responses will help ensure that the systems we design are reliable and safe to use. That will be all.